Get up and running. Let's get up and running. Get up and running. Good evening, everybody. Good evening, everybody. Few things to talk about today as far as what's going on with this thing. Just the intro. I know nobody's here yet, but just the intro for those that are watching late. We started on this build yesterday for the steering the steering servo mount, and this is what we were looking at. This here for the servo on this side, the receiver in the middle here, and this part here is the other bearing for the servo. I wanted this to be a little more beefy than normal because the last bracket I had was kind of flimsy, and it showed whenever I would make those hard turns, I could see the servo moving around in there, and then also it would bend the chassis a little bit. So I mean, that had a little bit to do with me trying to overextend it as well, like with my servo settings, but also I shouldn't have been getting that type of flex. So I set out to correct that, and this was the result of that, and I end up tearing all of this out. So what's there is just the area that this bracket here is gonna go. We watched this get printed out yesterday. I promised that I wouldn't put it together without y'all, so today we're gonna put this together, and then we're gonna move to the next step in the next phase of things, which would be to figure out where I want to put the ESC. I have a bracket already that I had pre-done. This is the bracket that I created before. And originally, the ESC was going to go here and the receiver was going to go down in here. But then I changed up that whole logic. So this is just another iteration of, how you come up with a design and you get cracking on it, then before you know it, you're creating another portion of that design because you've thought of something better. So that's what we're doing here today. We're making this thing better. It's going to steer better. It's going to be more durable. It is adding a little bit of weight to the chassis, but that's okay. This thing is still going to be wicked fast no matter what we do to it at this point. I have two what do you call it? Two bearings that I'm going to be pressing inside of here on both sides, and that's just going to keep that bolt in place. But you'll see. Let me see. I think I gotta pull them out of the old mount that I had. Popping right out. And I forget the size of these bearings. Um, I'm working with 3 different size bearings, and so sometimes it's easy to lose track of exactly what's going on. Got my Nimpics. These are really great to have. They don't have teeth, and you can adjust them to whatever size you need them to be. I use this a lot for pressing fittings down and pressing my bearings in place and stuff like that. Really cool to have. So we'll get started on this one. Lock that one in. More tricky because I rounded the edges off in the center side. If possible. If possible. Possible, if possible.
Are you making my guitar?
No, I'm gonna do that later now. We just have to print it out. Both of them locked in. Also gonna go with a 5 millimeter screw. On this one, I went with a M4, but we're gonna drill out yep. So we'll do an M5, so that comes out really good. Pull out my M5s. It'll take a while. Position where you can play with it. Play with something. So we gotta see how long do we need the screw to be. Press this in some more. Short. See if we have a longer one. You know what though? That space that I put in between there should have been enough. So let me see how I can handle this. My logical mind is saying to put a nut on this side and tighten it up and see if that presses down on those sides and give us more leverage. So that's what we'll do. Hello for the ones that's just joining. Now we're just picking up where we left off at yesterday. And get a wrench on the other side. I gotta go the other way. This way. Bigger. We're getting somewhere. Oh man. How's it going out there? We gotta hold that nut while we make it tighter. Hopefully I have enough give inside of this thing that it doesn't split once we start applying pressure to it. Because that happens quite a bit. Sometimes you can make your parts so perfect and precise, and once you start pressing fittings inside there and bolts, it breaks.
Side. I don't know how. Like this.
Yeah, you don't have the plastic trays in there no more.
Like
So
this.
you just set it in there and then close it up. You know the plastic pieces that you used to have? So
I can keep this.
yeah, just hold on to it.
I can keep this.
Yeah, hold on to it.
The purple stuff.
Yeah, just hold on to it. until I make yours. Okay. So the goal was to press this, to use this as a leverage to make the bearings go closer together from the back end. What will end up happening is just it just got tighter. No movement happened. So what we're gonna have to do is just shave a little bit off of my my servo horn, which will happen when I drill that hole out because I originally used a M4 size hole, but we need the horn to be open to the M5 now. Ooh. And I want it to still kind of be snug so that the screws onto um that horn rather than it being loose. For this, I probably should be using the nips so I don't hurt myself, because that happens quite a bit too. I guess that's the emotion of just being excited about doing something or getting something done. Sometimes you don't go and do the extra safety measures, and then that's when you end up drilling through your thumb or something crazy. Here. In there. And, well, go to the bathroom. Go to the other one. Hold on a second, y'all. Let me make sure this girl gets to where she need to get to. Be right back, guys. Just a second. All right, I'm back. I'm back. Please don't forget to like the stream so that the algorithm can take it and do what it needs to do. So this is what I was talking about, how it doesn't just fit in. I have to screw it in there. That's kind of what you want if you're going to be doing your own horns. You want it to fit snug to where it's got a little bite. So it's snug, but it's not sturdy to where we can't move it if we need to move it. And that's just gonna go uh through the bearings here, and the nut on the other side is gonna hold it in place. And that's just gonna actuate like that. Put it on upside down. Yeah, put it in backwards. Don't forget to like the stream. Don't forget to help them algorithms do what they need to do. Yeah, so I did have it on upside down. Uh, The best nuts to use on these are the nylon threaded lock. But I don't have them, so when I want it to be set in place, I'll just put a little tight a thread lock on it, and that'll hold it in place too. That's just if it comes down to it, and you need to really lock something in, have you some tight lock or some thread lock. I call it tight lock, but you know, y'all know what I mean, right? We'll work this loose. Trying to really get more of a press fit in there. I didn't know that my M5 screws was this short. The more we work it, the looser it'll become, and then we'll be good to go there. All right, so now we got that set, right? That's where it needs to be. We go ahead and put the servo in. Servo has to be facing forward as well. And I set out for these to be the same height. That's how we wanted to design it, to where they would come out to the same, they would stick out the same distance. That's kind of important, especially if your your limited space inside under here like I am. Like the space under here is really limited. So these measurements had to be, they had to be within the centimeters, you know, of tolerance. So you all will see once this thing goes all the way together, you'll see exactly how much clearance I have left. And I really did make it really close. Um, but it worked out. It did what it needed to do. It don't always do that though. Sometimes I'll do a design and then it looks good in the CAD software. And then once I print it and it comes out, it's all, the dimensions are all different. Feel free to comment and talk too. I got this stream to where I can see if you all are saying stuff. If you got any questions or any suggestions, you know, I'm open to it all. You know, just gonna lock this servo in. And please make sure y'all like the stream so the algorithms will keep pushing it. What I didn't do any inset like I normally do. Just trying to get it done. Last night I was getting a little tired, and the kids they were making all kind of noise, and I was like, oh my god. It's something about those kids. Whenever I want to do like a live stream or a video or some sort, those kids they get so much energy. But if nothing's going on, oh yeah, they're the quietest thing. Moment you decide, yeah, let me do something productive, they just go crazy. Drop the screw. Always got my trusty dandy a magnet here, so I don't have to try to bend all down and get all out of shape to get it. But this really is kind of like my Lego blocks, you know. But it's like I don't have a roadmap. It's a Lego block set that I don't have the instructions to. Any of you all feel like that with your projects? You're just trying to figure it out as you go. Nobody's doing it, so there's nowhere to get the information. And I wanted this thing to be beefy, but I didn't know it was gonna be as thick as it is. Uh, Before printing it out, once I saw it come off the bed, I was like, man, I went a little thick. But we'll see how durable it is. Hopefully, it's as durable as it looks. You know, that's the end goal is that it's as durable as it looks and it actually performs how we designing it to perform. So now eventually, I'll get around to doing um the frame again or the chassis part. But for now, I've just been screwing the screws right into the plastic on these. But when I get ready to redesign the chassis, that's gonna be a little thicker, and then I'm gonna do some heat inserts for that as well. So this goes down in there just like that. Simple design. We'll put a couple screws in it just to hold it so we can play around on the other side. One thing too I noticed that I forgot to do was to uh to offset these holes so that the tops of the screws could sit down in there flat with the plastic. I forgot to put that in the design, so I'll just drill those out. I'll drill that out and then it'll be a quick fix. So now on this side, this is where everything gets really tight because I went so far forward. And I was thinking today I might have to redesign this bar just so that I don't hit any corners. So we'll probably end up designing that today. We'll get to a little bit of that. But I'll throw some screws in here randomly just so we can see where it is. one. We'll make this one kind of longer. And this side is loose, as always. That side has worked itself loose, so that hole would need to have a nut on the other side or something. I'll think of something for that. I'll probably end up going with aluminum inserts on that as well, or to go with the aluminum horn. But this is where we are with the links totally closed. That's how I wanted to start it out so that I can adjust. So the wheels, they sit outward a little bit. They're facing outward just a bit. But I wanted that to be where the adjustment happens. Because as you lift up the suspension, the toe is gonna point inward anyways. See how much space we have in there? Like that is it's crazy how much space we have. Like barely. But like just the slightest turn of this is where we need to be before we start eating away at our diff box, which is one of the challenges with the hydraulics is having a diff box right there, um, having the suspension to go full extent the way you like it, and still have that allowance. And then also how I offset the how the links attached to this bar, um, they bump the inside of the horns here. So I didn't want to put it to where the horn would need to turn so far to give us that turn. Like right now, this is plenty of turn, but we don't want it to go this full amount even. We'll probably back it out to where it's only turning about that much. But still, that's enough for what's going to happen with this vehicle. Um, so what I would do is turn it on, power it up and adjust the settings, and then take measurements based on the ride height and all of that stuff, and make sure that uh, the servo isn't going to kill the plastic frame and all that stuff. But we'll get this all set, line it back in. I'll have this taken apart so I can play around with some ideas for how I'm going to be mounting the ESC. I wanted to I wanted it to be clean. Goes down in there nice and smooth. This area here is going to be for the all the wiring and stuff, all the access wires that I'm going to be having. I'm just going to be hiding them away over here inside of this little thing. And when I was younger, man, I used to be so meticulous with being precise and having things to line up. It like things had to be perfectly set, and I didn't get a whole lot done because I would be constantly trying to redo things and undo things and make things more perfect than they have to be. And I've gotten to a place now where I just got to move on past that. Like, it doesn't have to be totally perfect. It just has to be functional, you know. If you can get to that point where you make it functional and you're happy with it, with the way that it's moving and acting, then you're good. But yeah, I used to, even if something was working properly, I would just still find a way that, oh yeah, this could be done a little better, and then I'll undo it and I'll jack some stuff up trying to make it happen. But let me grab my transmitter. All right. So one thing too that I did while off camera was I fixed that back axle and I beefed it up. You know, made it put it back to where it was at. So this is at its low point. Um, I'm just gradually pushing the stick to see exactly where it stops or if it binds up anywhere. And the moment that I see the plastic pulling away, I know that it's pushing too far. So that has to be adjusted inside of the settings. So I will go in the settings of this and I'll adjust how harsh that movement is on that stick. And I believe that I'm on uh channel 2, I think, for this stick. It's either 2. Let me see. I'll be forgetting what channels I have this stuff on. Let me see my input. Oh, it's on 1. So right now I got it set to 75% weight. So just by changing, if I change my weight to like 65, that'll cut down how far this thing is turning. And so what I like to do is set it really low, open up the switch all the way in one direction, and then toggle that number until I see it line up exactly where I want it to be. So like right here, I'll flip it upside down so you can see what I'm talking about. All right, so all the way, if we go all the way over, we have a little space in between there. Now the idea is to get as much turn as you can without causing issues to happen where things are bumping together. So I would look at it right how it is now, and I will toggle that number, and I can see it slightly moving as I toggle the number. And also this is loose too, so it's gonna be given some leeway and some put and some. I don't think that much needs to be done as far as that level there. But the challenge is once we take it up and we change to a different height, that's when the challenges start to happen with the turning, because then you start to get binding. But right now it's still looking good. We're not hitting the case. We're clearing the diff box. We're clearing the arms. The toe doesn't look bad either. And then all the way up. All the way up, it looks like there's a little binding going on here. Here, let me. So for this part, it might just might be the idea of taking that extension down for how much percentage I'm using inside of those front servos, because the whole diff is moving. We don't want the whole diff to move. The whole diff is rocking backwards. So about there. So we end up at about 63. So what I'm gonna do is I'm gonna take it down to 60 just to be on the safe side for that steering. But I do want to go over to where the front suspension is doing. I'm gonna do the same thing up there. The front suspension I have on 100%. I had these both set to 100%. So let's look into that. Let's try to see if I can adjust that. So right now, that's medium. Well, let's go again. What I did was I created a mix for this so I can use the the VR knobs on it as well. And when I did that, I took away the idea of, or I took away my ability to change the weight right there. So I may have to go into the mixed setting in order to change that. Over here on channel, I think I was channel 3 and 4. For the 65 is what I had it at already. So it wasn't extended all the way as it was. Oh, and I have an offset as well. Okay. See, it's been a while since I've been inside of here. So I kind of forget what I've done, but I don't see it moving. Yeah, let's see. Or maybe I have to toggle the offset. There we go. It's bumping now. So see how that relaxed? I don't know if y'all caught that, but it relaxed a little bit once I started toggling that number. But what we want is we want it to relax all the way down to where it's not like our full height should be. Let me check these screws. It just seems like it's way too loose for these screws to be tight. Either that or I need to redesign that and make it thicker again. But there's a lot of play on that. Yeah, I think that's a design issue that I need to look into. Let's have a look. So I guess
I'm guessing it is just flimsiness, and so that might have to be a solid piece. So when I go in to print the next version of this, I'm gonna have to consider how much infill I'm using so that it doesn't have that type of flex. We don't need it to have that type of play. Yeah, it's iffy. It's most definitely gonna have to be just as sturdy as the servo or the steering servo mount is. Yeah, I'm not a fan of that wiggle. That's wiggling a little too much for me. A little too much for me. But the overall steering portion, I'm all right with the overall steering. Yeah, I don't like it. That flimsiness could be sitting out there. And so let me put a nut in there real quick and kind of keep this thing together while we're looking at it. All right. So we managed to take this thing all the way back to the center point as far as it being middle, which is not really ride height. All right, so -10 is what we're setting at. So now I just have to go over to the other side and do the same thing for 4. Use the offset. Moves down to -10, I believe. Oh, I went the wrong way. There we go. We're just lowering it down to a safe distance. We got a little bit of bind. And that bind could have a lot to do with this differential not sitting sturdy as well. Because now that's fine if it's sitting like that locked into place. All right, so there's a few things that I can do as far as making sure that diff sits where it should sit and not move. Now I can create a bottom rail. I can create a bottom rail for this thing that will secure it in place. And as we were doing that, we lost connection with our drive rod too. That's why I do a lot of this um, testing. Like you have to do the testing because sometimes it'll look like it's together and it's ready to play with, and then there'll be something minor, something small that throws the rest of the functionality off. So that's what we're experiencing right here. This is a minor fix, but if you don't catch it, then you send it out to people for them to build it. You are in charge of, you know, how much trust people have in you and in your designs when you release stuff to people to build and it doesn't work and it's not functioning properly, you know. So um I try to do my due diligence with this, making sure that I do get it dialed in right. So when I do release files, people are not just wasting their material printing things out and um they end up having to wait on the second version or a better version to come around. All right, so um like the same thing that I did for this for the rear diff, I can do the same thing for the front as far as keeping it in line and taking away this flex that's happening here, because that's a no-go. That flex is gonna end up as a break, and it'll probably be when somebody hits a bump or rams it into a curve or something like that, and the thing disconnects from the plastic. And we don't want that, We want it to be sturdy. Um, like I said, a couple options, a couple things I could do is um, change the bracket thickness of where how we have the mount, how we have the diff mounted to this the chassis, because this part here is just a one rail ordeal. It's not secured down to anything else other than just being a little U-shaped bar, and which it used to be thicker than this. There was some thickness to it, and I got a little zealous with the design and trying to trim it down and trying to make it more sleek. But I lost some integrity when I did that. So in order to regain that, I'm gonna have to either add some more weight back inside of this bar here, this center bar. Um, I can't remember with the files. I'll have to look at the file that I printed
to see what that infill was. But this may be one of those parts that have to be 100% or damn near close to 100% infill for it to have that rigidness to it. Um, Another option too would be to uh, uh, attach both of these together and create it, make it as one unit. The uh, the diff mount and the servo mount for the steering. I can have those go together, and then that could take away that flex as well. You all have any? Please get in the comments. If y'all have any ideas of ways that I could mitigate that problem of this flex that's happening. I didn't foresee that flex, but maybe going taller on the top side of this bar and having a longer screw would give it more sturdiness as well. Because I think right now I'm only securing into maybe about a 1/4 inch of that plastic because I have the screws inset. Now the thickness is, yeah, it's hard to get in there when you need to get in there. I guess I'll just eyeball it. We're looking at about point 0.4. So a little, that's the total thickness. So the inset is probably only a point 0.2, which is probably not enough. So what I can do is go in and we take this thing up and make it more beefy and do another printout. So let's jump over to the CAD. Let's go look at it. Jump over to, not Creality. Let's jump over to Fusion. Um, that's what we was working on for the steering rod or steering mount. So let's go. Maybe this is the one. I have a new CPU coming from my computer, and I can't wait till I get it. It's supposed to help me to help for this thing to handle all of this data better. Sometimes I'm waiting too long for, like, if I'm trying to change something, I'm waiting for it to do what it needs to do. Let's see what that body is. Now it's a matter of finding which mount we're working on. I think this is the one here. Yeah, this is the one here. So I went so thin right here, and this is the only part that's securing the diff. And so I think that's the problem with that flex here. Yeah, that's the problem with the flex. See what that distance is. But yeah, that distance is a 0.205. Not enough. And like when you're designing, it looks good and you're designing it. But you like sometimes you don't keep in mind that, all right, you need those screws to be longer so um you have more meat to chop into. So what we'll do here is pull this out. We'll say I want let's see if we can use it longer.
We can get probably a 0.5 bite on top of that 0.2 that we're at right now. So let's push it up. Let's pull it out 0.5. 0.5 should be good. 0.5, right? Now having this much space, um, for the screw to rest up against gives us enough anchor, for that to not flex like that. Uh, so we pull that out 0.5, and then also we'll pull the inset out 5 as well. And it's a simple fix, like I said. Like a lot of these tweaks and stuff that, like, when you're doing your own projects, a lot of these tweaks are very minor if you don't overthink it. Just figure out, like, if you design a part and it's not working for you, you just kind of pick it apart and start asking those questions about why it didn't work. Like, was it about it? What was the response? Um, or what was the indication that the part is failing? And then you're looking into how to mitigate that happening. So see, now we're at 0.7, which is a little over 3/4 of an inch. So yeah, I'm all right with that. I'm all right with that. I mean, I could take it in a little more, because that much may not be necessary. So maybe I'll push. Maybe we'll push back one. We can push back 0.1. I don't want to overdo it, but I do want to make the point. So we're gonna go negative 0.1. See what this gives us. 0.6, a little over half inch, which is that's all right. Yeah, 0.6 is reasonable. I'll take this in again to push that back. Negative 0.1. So simple fix like that. We'll send this thing right over to print, and we'll just chop it up and watch this thing do its thing. And we can work on something else while we're waiting on this to do what it do. But overall, I'm excited about where this thing is going. How far I've come in this design is crazy. If you've seen like the very first design, man, it was so basic, and uh, I did like the bare minimum, and now it's like it's getting really good now. It's starting to make sense. Make sure that we didn't undo any other features while tugging away at that. See, pulled this. Maybe this got pulled out a little too far. Let me do that. I'll just leave this as is. I'll leave it how it looks. I don't think we lost anything structurally by pushing. Still have that wall thickness. So we have that thickness there. Also, um, let's add to that outer structure wall thickness. That'll be another part of it to do as well. Do here. Because I don't want to go back too far. So maybe this thing should be at least a 0.5 thickness. Any of y'all agree with me on that? And as far as taking this thing down to its bottom, we're doing good as far as clearing that edge. Yeah, so let's add the meat to the back end. That's the way to go. I think that's the way to go. So get out of that. Let's check this thickness, and we'll just add whatever is missing. So we're at a point. So we're just only gonna add 0.1. Maybe it should be more than a point. Maybe 0.6. Let's go 0.6 like we did this thickness. What you need, baby girl? What you got? No, I didn't start it yet, baby girl. I have to. I'm still working on that design. Bye. I love you. 0.2. Give us that. Yep, and because we did that, we're gonna have to just walk these sides back out as well to blend in 3.5. 3.5. Nope. 3.2. Sometimes these numbers be off and like just you go down a rabbit hole of trying to chase down what the right number is to get this to do its thing. All right, so what I'm gonna do is whenever I get numbers like that and it's not adding up, I'll overextend and then I'll just cut it out. I'll split the body. This is like the fastest way for me to do it, based on my knowledge. I know there's people out there that can get this done without doing what I just did, but sometimes it's frustrating to be chasing it around and not exactly understanding how to how to navigate the software. I'm fairly new to the software still. So whenever I'm doing this stuff, man, it's a matter of me dealing with my learning curve. there, and I got rid of that little chop there. But that's usually how it goes when I'm trying to fix on a prop on a design. I end up with these unusual shapes and sizes. Also, I could have just extruded the other side too. I could have extruded this side. Then I wouldn't have had to go through all that cutting. But see, that's how in my mind, you know, things line up or don't line up right away for me. And I'll end up doing extra work rather than doing something simple like what I just did. Yep. So got that. Um, and then this little portion here and on the other side as well. Cleaning up the works. Can't wait to get that processor. Once I get that processor, that doing stuff like this is gonna go so much faster. All right, so we beefed it up. Now we're looking to print this out, how it is right there. Hopefully, just hopefully, it gets the job done and it gives us that sturdiness that we're looking for. Oh, what's this? Oh, the bottom side. Okay. We gotta reattach that. It's looking good. All right. So now I'll just send it over um to Creality. Save it already. This is exactly what I'll be talking about. It's redoing some geometry and it'll be thinking and doing some other stuff, and then I'll be just sitting here waiting on it to do what it needs to do. And y'all can't see these props. I don't know why you can't see the props, but I'm clicking on stuff to make this happen. Then we'll go over to Creality. It's gonna give us a new window here in a second. How y'all doing out there though? How's everybody's day? All right, let me see. Here. Going to be printing from the bottom. Faster to print that way. So like the bottom face. This center area here, we will add a modifier to it. add modifier, and you all can't see that I'm toggling on some. What I did was I right clicked the item, and then I'm gonna add a cube. Switch to up there. Drag this cube over here. Cube has to be inside. Scale it. What this cube does is it will give a different infill than the rest of the part. Now I already, as it is, um, I do a lot of the infill as a wall loop, so that I don't have to worry about uh if I want to drill a hole or something like that. I don't have to worry about um drilling through a part where it's like 50% infill, and then the hole doesn't have integrity. So I like to keep my walls above 5. So if I have like a hole, it's gonna print a bunch of meat around that hole, and if I need to drill it out, I can still drill it out. In this case, we want this to be solid right here. I love you. What's that? Oh, what happened? From the sink? How'd that happen? Washing your hands. All right, so we got that whole area covered. Um, so hopefully, doing it this way is going to give us that sturdiness, in that section. I'm using ABS. I love using ABS for this type of stuff. That one little. I'm actually curious because normally I when I print this, all of this bottom area is normally supported, but for whatever reason, it just puts supports there on the side. But we need more support than that. I need this thing to act right for me. All right, so I'll go into the global, go to my supports. I have my threshold set at 10% or 10 degrees or whatever. So we'll take this up to, let's see what it looks like at 20. Does something different for us. Nope. Same thing, huh? All right. Maybe it's because I got that modifier in there. Pick it up to its normal. Normal is 30. Try doing a normal automatic. There we go. I guess that's just the way we had to do it to create that. It's telling us an hour and 56 minutes for this print to happen as is. Checking this. You need help with. right, girl. Hold on. I'm gonna make sure this is set and ready to do what it need to do. So that'll teach me to change things around. Seeing firsthand what it's like when you start skimping on the project and trying to cut the corners. So what I'm looking for here is I'm trying to make sure that those blue lines are against the direction of the green lines. Because if they are just in the same direction, they tend to stick together more, and it's harder to break the support loose. Um, and then you can readjust the direction of those slats if you need to, and you can do all of that in those settings. And around with all this stuff down here, the pattern angle. I can go in here, I can change the pattern angle. Say 5%. Let's see what that does. Or to 5 degrees. This kind of just gives you an example, but see how it shifted it 5 degrees, kind of. That's not a huge difference for y'all to really see. Let's do 25. 25, it'll be noticeable. But this is just to give you an example of how to maneuver this. But see how it crosses it rather than splitting it down the middle and going the same direction as that first layer. So these are things that you all want to pay attention to as well. Because the thing that you want most is a smooth part when you're printing. And then the hardest thing is to print with supports and to have that surface that meets those supports to be smooth. And so this, when you have this set up like this, um, it just guarantee, well, don't guarantee, but it gives you a better uh gives you a better chance of having a smooth break free from that, and not have to be wrestling with it or prying away at it to get it loose. All right, so we got it where we want it. Um, and we're just gonna let it rock. We actually cut some time off by doing that. But we're not rushing this. This is just gonna be another part added on to the other many parts that we printed to get where we want to get to. So we'll start this print, and then we'll just go back over and start talking about uh, what was happening with that binding there, and which I thought it was binding at first, um, but turns out that it's just the thickness of that supporting part for the differential is too thin to carry the weight of the servos. So, and I'm still trying to figure out, and I can't figure out for the life of me, these numbers here, when I've started to print. So we just recently had a update on the software to 6.3, and when I installed that software, that update, it made this thing go haywire. So now it doesn't populate properly. So if a print tells me that it's gonna take 30 minutes to print, this will say 30 minutes. It'll say 30 minutes, but when I'm actually looking at uh, at the information, I could be looking in this. I could be looking inside the inside of the machine, and it'll look like I'm on like layer 10 already, but in the software, it'll still say I'm working on layer 1 or layer 2, and I still haven't figured out how to correct that. I tried uninstalling the program, reinstalling it. Still getting the same thing going on. Sometimes the camera doesn't link. It's so random how this thing has been behaving lately. Sometimes I have to stop a print on the software because it's done inside of the K2. And so in order for me to get to where I can start printing a new part, I gotta shut this down and open it back up for the new part. So I mean, I hope they fix it and get it right. So that's something the one less thing I have to worry about. Another funny part too is that these numbers on the X, Y, and Z axis, they'll be populating too, like the head is still moving, but literally the head will be at the home position and sitting still, but those numbers will be counting like there's something going on in the machine still. Might not give us a visual. It's probably not going to give us a visual. So if it doesn't give us a visual, then I'll just bring in the other camera. I'll bring this camera in for us. Oh, it's looking like it's going to pop up for us. The camera's doing something funny here. When you make that thing, such a good job. Let's see what's happening here in this. Well, I got a bunch of non-responsiveness going on inside of this platform to be working it out.